All right, so the purpose of this video, okay, is to give you a little bit of homework help on this Vertex form of quadratics. I saw some people had submitted some homeworks on Schoology, and there was a lot of things that I saw that were incorrect, and I also saw that a lot of people didn't turn it in. So Vertex form homework help. We're going to run through some problems that are similar to your homework so that you then have a couple options. Number one, maybe you can then finish your homework and get it submitted. Number two, maybe you did submit your homework but you didn't get full credit. You can then make corrections and resubmit. Or really option number three is if you did already get full credit, use this video as a review. When I put a problem up, you can hit the pause key, try to work through it on your own, and then fast forward and see if you did it right. Okay, so there's something in it kind of for everybody. All right, so here's what vertex form looks like. Vertex form looks like y equals a times quantity x minus h squared plus k. So the first thing that we need to do is we need to review what vertex form, what each piece means. All right, this a value right here, this is the vertical stretch or shrink. Okay, so not only does the a value affect the opening of the graph, but it also affects the width of the graph. All right, we'll talk more specifically about that in a moment. If the a value is less than 0, okay, it's an x-axis reflection. If the a value is positive, then there's no reflection. Okay, so that's what that a value does. It determines the opening, which is the reflection, and it's the width of the parabola. Now, this right here is going to be the horizontal shift. This is what moves the parabola left and right, which therefore moves the vertex. If it's x minus h squared, you're going to move right h units. If it's x plus h squared, we're going to move left h units. Just, kind of a reminder here that it's always going to be the opposite when it's in that parenthesis. Okay? And then finally over here we have this k value, which is the vertical shift. And this is the other part that also moves the vertex of the parabola. Now this one's a little more straightforward. If it's plus k at the end, it's going to move up k units, and if it's minus k, it's going to move down k. So the two parts in vertex form that are going to determine the vertex is this part right here, okay, specifically this part and this part. And those two parts that I've highlighted, those two parts are the vertex. So the vertex is going to be the h number, comma, the k number, okay? And again, when we get the h, we're going to have to take the opposite of what we see in the equation. So if it says x minus 4, that actually means that it's a positive 4. All right, so let's work through a couple problems to help with, on your homework, to help with numbers 1 through 6, if that was something that you needed to fix. If you feel confident with 1 through 6, you could either pause the video and try it on your own, or you could even fast forward and find a different part that you had trouble with. All right, so y plus 2 equals 3 times x minus 4 squared. I want you to name the transformations. Okay, well, I did this a couple times on the homework where we're not exactly in vertex form because we need to rewrite the equation and get the y by itself. So what we're going to do here is we need to take this y plus 2 and we need to bring it over to the other side. And so vertex form is going to be y equals 3 times x minus 4 squared, and then we need to tack on the minus 2 on the other side. So keep that in mind that sometimes we need to do a little bit of work to get the y by itself or reorder it and put it in order. Okay, so this 3 right here, okay, if we name our transformations, this 3 right here, that is going to be the vertical stretch. And this is going to be a vertical stretch, and I know it's a stretch because that number is greater than 1, of 3. Okay, I'm not going to mention anything about a reflection because that a value is positive. The next part right here is the x minus 4. The x minus 4 is going to cause a horizontal shift right 4 units. Okay, the last part right here is going to be this minus 2. That minus 2 is a vertical shift, and it's going to cause it to move down 2 units. Now, just to kind of add this in, let's remember the vertex comes from these two parts right here. If it's shifted right 4, then the x-coordinate is going to be positive 4, and down 2 is going to make the y-coordinate negative 2. And so that is how we can, by looking at the equation, okay, if we come right here, look at the highlighting, if we take the opposite of this number, positive 4, comma this number, that right there is going to be the vertex. Okay, well, the next thing that you were then asked to do in the table was to write an equation, okay, write an equation given some transformations. So let's suppose there is a vertical shrink of 1/2. Let's suppose there's an x-axis reflection. Let's suppose the vertex is shifted left 6 and up 4. Okay, and then what we're going to do is we're going to write an equation in vertex form that reflects all of these transformations. So let's go ahead. The first thing, y equals, well, the first two parts that I see right here, this part and this part are going to affect the a value. Well, the vertical shrink makes the a value is going to be 1/2, and the x-axis reflection means that I'm going to make that negative. Okay, so we got those two parts covered right there. Now, we're going to do a quantity, and if it's left 6, okay, then that means that the h value, right, is going to be a -6, because that means that left 6 means that it's shifted over to -6. So when we go to write this in vertex form, it's going to go x minus, and then we're going to plug -6 in. Well, what happens when we have minus a negative? Well, that's right there why it looks to be the opposite. Left 6 means x plus 6 squared. All right, so that part right there is going to be the quantity. And then finally, what we see is the up 4 part is going to mean that we're going to tack on a plus 4. Okay, so that's how you're going to write it. That should help you with numbers 1 through 6 if there was something there that I had you fix. Now, this is the part that I would expect I want a lot of people to pay attention to. On your homework, we had a little issues with number 13 and number 14. So I picked out an example that will help you with those. Okay, so what you're going to do is you are going to write a quadratic function. Now, in vertex form and standard form. Okay, number 13 tells you to write it in vertex form, and number 14 tells you to write it in standard form. So we're going to do both at the same time, here, right here, okay? With a vertex of -1, 4, and it's passing through this point, -3, -8, okay? Well, here's the thing that you need to understand about writing these equations. Because of the given information, because they are telling me right here that the vertex is -1, 4, it doesn't really matter if it says to write it in vertex form or standard form. You have to start with vertex form because of the way they gave me the vertex, okay? So you are going to plug the vertex into vertex form. Okay, so let's see what this is going to look like. In the vertex right here, this is going to be the h value of the vertex, and this is the k value of the vertex. So vertex form looks like y equals a times x minus h squared plus k. Well, when we plug this in, we need to leave the a value because we still don't know what the width of the parabola is. But it's going to go x minus, and then we're going to replace the h with a -1, right? And we're going to square it. And the k value is going to be 4, so we're going to tack on a plus 4. All right, let's fix this up a little bit like we talked about before. Rather than having x minus -1, that means it's going to be x plus 1 plus 4, okay? So that's the first thing you need to be able to do is you need to be able to plug a vertex into vertex form. Step 2, you need to plug in the given point, -3, -8, and you need to find y, or I'm sorry, not y, to find the a value, okay? So here's what we have so far. a times x plus 1 squared plus 4. Now the given point is going to be -3 is x and -8 is y. And so y, well, let's do this. Sorry, I'm going to back up. I'm going to replace the y coordinate with -8 equals, we still don't know what a is, and we're going to replace the x coordinate with -3. Okay, so now what we're going to have is this little equation where what our goal is to figure out what this width needs to be so that it passes through the point. Let's keep doing this math right here. All right, I'm going to leave the a, and I'm always going to start with my parentheses and my exponents. -3 plus 1 is -2 squared plus 4. I'm going to keep going right here. This is going to be -2 squared is 4, so this is 4a plus 4. Make sure, I'm going to put this in green, but make sure you don't do this. This is what I see people do, is they put the 4 behind it, and then they incorrectly want to add the 4's together. So make sure we don't do that. Put the 4 in front of the a. Now, when I keep solving here using, I'm going to subtract 4 from both sides, and this is going to be -12 equals 4a. Divide both sides by 4, and we finally get that a is equal to -3. So after all that work, here's what we finally get. We get that the vertex form is y equals -3 x plus 1 squared plus 4. Okay? Now, how do we get this in standard form? Well, to write it in standard form, you still do all the same steps we just did, but what you're going to do is you're going to expand it out, and we're going to multiply this out. And so to get it in standard form, I'm going to make a quick note, you are going to multiply out the vertex form. Okay? So let's go ahead and multiply this and see what happens. So I'm going to go ahead and multiply the x plus 1 and the x plus 1, and we get x squared. 1x and 1x is going to make 2x in the middle, and 1 times 1 is going to make 1. Okay? I'm going to distribute the -3 to all of these terms, and it's -3x squared minus 6x minus 3. And don't forget about bringing your plus 4 down. And finally, it's -3x squared minus 6x plus 1. And so the vertex form right here is what I'm highlighting, and the standard form is right here. So that's what threw a lot of people on number 14 on the homework, is it said to write it in standard form. You still start with your vertex form, you still plug in the point to find a, but this time you're going to take your vertex form and you're going to multiply it out, and that's how you get it into standard form. Okay, the last thing that I want to help with on the homework, we had a little bit of issues with graphing. Okay, so on the homework, this is going to help on numbers 7 through 12. So if I wrote you a note about needing to fix the graphs, this is the part you want to listen to. All right, I'm going to add in a little bit of graph paper right here. All right, so let me just rewrite this real quick. This, again, is homework help for 7 through 12. All right, let's just run through a couple of examples on how to graph in vertex form. Y equals 2 minus x plus 3 squared. Okay, well, first off, this problem is not written in the correct order. So the first thing that I'm going to do is I need to take the 2 and I need to tack it on in the back. So this is really going to be a negative x plus 3 squared, and we're going to scooch the 2 over to the back and tack on a plus 2. Okay, well, what we need to be able to get by looking at this is we need to be able to identify the vertex, and we need to be able to identify the a value. Those are the two things that we're going to graph. Well, the vertex is going to be, okay, the opposite of this number, and so the vertex is going to be -3, right, because that x plus 3 means left 3, and it's going to be this number, so the vertex, that plus 2 means up 2, so the vertex is -3 too. The a value is right here, and since I don't see a number in front, I assume that it is 1. So we can go ahead and call the a value -1. This means two things. First, it's going to open down because of that x-axis reflection. The second thing is it's going to have what's I consider a normal vertical stretch. So if we know how to graph the equation of a normal y equals negative x squared, then it's going to have that exact same width, okay? So let's go ahead and let's kind of talk about how we graph y equals x squared. And then we're going to compare that to how we graph negative x squared. So what you need to understand about a parabola, I mean, almost to the point where you just need to memorize it, right? That a normal parabola has a vertex at 0, 0. And so when you plug in 1 and you square it, you're going to move up 1. When you plug in 2 and you square it, you're going to move up 4. And so what parabolas do is they move over 1, up 1. Okay, I'm just kind of looking at this side right here. What parabolas do is they move over 1, up 1, over 2, up 4. What would we do if we moved over 3? You're exactly right. We would go up 9. If we moved over 4, we would go up 16. Now, a parabola that's negative x squared, what we would call a normal parabola, is going to start at 0, 0, and it's going to go over 1, but it's going to go down 1 unit. And it's going to go over 2 units from the vertex, and it's going to go down 4 units, okay? And so that's how you graph a normal parabola. Over 3, and it's going to go down 9. And so that's really what we need to memorize. Over 1, down 1, over 2, down 4, over 3, down 9. So when we have that vertical stretch, it's these vertical distances that we end up multiplying by the a value. All right, so with all that being said, all right, finally, I'm going to come back to this parabola. This was negative 1, what was that? X plus 3 squared plus 2. Let's go ahead finally and let's graph this parabola. So the vertex we said was at negative 3, 2. So negative 3 right here and positive 2. Okay, and because of that normal vertical stretch, I'm going to use the same pattern that I just did right here, and we're going to go over 1 unit and we're going to go down 1 unit each way. And then we're going to put our pencil back at the vertex and we're going to move over 2 units and we're going to go down 4 units each way. Okay, and then what's nice about parabolas is because of that axis of symmetry, all we need to do is flip this point, reflect it across, and there you go. You've got a parabola that was pretty easy to graph using 5 points. All right, let's try another example, okay, and let's maybe change that vertical stretch a little bit. Let's say we do an example of y equals 3 times x minus 2 squared minus 6. All right. So first thing, let's see if we can quickly identify the vertex. That, after all, is the perk of vertex form, is we can see the vertex in the form. Well, this part right here means it's shifted right 2, so the vertex is going to be positive 2, and this part right here means it shifted down 6, so the vertex is positive 2, negative 6. The a value this time is 3. And so when I go to graph this, again, this is the way, I'm going to do this in blue. This is kind of my thought process. This is the way that a parabola graphs. This is what we have to memorize. We go over 1, up 1, over 2, up 4, right? Well, when we have a vertical stretch of 3, we're going to multiply all these vertical distances by 3. So let's go ahead and let's graph our parabola right here. So the vertex was, don't like where I put that line right there. All right, this is positive 2, 1, 2, 3, 4, 5, 6. All right, positive 2, negative 6. So we're going to start by moving over 1 unit, but this time, instead of going over 1, up 1, we're going to go over 1 and move up 3 units either way. Okay, now what it's going to go on over here is now we're going to move 2 units from the vertex, but instead of going up 4, we're going to go up 4 times 3, 12, over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And because of that axis of symmetry right here, we can go ahead and reflect that point over and get 5 points pretty easily. So it's almost like what we're doing is, essentially we're using the slope to graph a parabola rather than having to do arithmetic and plug in points. All right, I'm going to do my last example right here. if you need. If you're good, then you can probably go ahead and stop. But if you want to keep listening to the graphing part, then follow me on one more example right here. Again, this isn't quite written in the correct form, so I need to scooch the -3 over. This is 1/2 x plus 1 squared minus 3. Okay, I'm going to probably need to wrap this one up because that was the bell. The vertex is going to be the opposite of 1, which is -1, -3, and the a value this time is 1/2. So what we're going to do is a guide, right, is let's come down here, and normally the way you would graph a parabola, again, is you would go over 1, up 1, over 4, oops, you would go, you can come on in, you would go over 2, up 4. Well, what we're going to do this time is we're going to multiply all those values by 1/2, okay? So when we go to graph this, the vertex is at -1, -3, and from the vertex, we're going to move over 1 unit, but we're only going to go up half the way. And then we're going to move over 2 units from the vertex, but again, we're going to only go up half of 4, so we're going to go up 2. All right, and so there we've got the parabola. So hopefully that helps. Go back to the outline, take a look at your options, and hopefully I get